Pluto is a bizarre dwarf planet in the far reaches of space. It used to be considered one of the main planets, but recently, well-known space experts Neil deGrasse Tyson and Michio Kaku said something surprising that got everyone talking about Pluto again. They believe it could crash into Neptune in some way. What would that entail, and is that even possible? I mean, if it did, would this be some super rare cosmic event, or is there something else going on with these two planets? Let's look at what could cause Pluto and Neptune to collide. Pluto, this former planet now classified as a dwarf planet because of its weird orbit, is still pretty interesting to scientists. These scientists say that Pluto's path is getting dangerously close. Tyson and Kaku are alerting us to the possibility of a cosmic collision, which could be bad news for Earth. How is that even possible? Well, Pluto's path around the Sun is strange. It takes 248 years to make one full trip around, which means it hasn't even completed a full orbit since its discovery in 1930. Plus, its path isn't circular like most planets. It's more of an oval and tilted compared to the other planets. What's also wild is that Pluto's path crosses Neptune's for about 20 years of its orbit. Pluto is actually closer to the Sun than Neptune during that time. So why haven't they hit each other yet? It's because of how the gravity of other planets pulls on them. When people started studying Pluto's orbit, they didn't understand it at first. It was very different from the other planets. Moreover, it crosses Neptune's path. The reason Pluto's orbit stays stable is because space is complex. It's tricky to figure out how three things, Pluto, Neptune, and the Sun, move and pull on each other with gravity. It's like trying to predict a destination based on where they start and how they interact. With Pluto, it demonstrates how the gravitational roots of Neptune and the Sun work together in a complex way. Something called vibration, together with a bizarre feature known as the VSSs, keeps things in order. According to space experts, AU, astronomical unit, vibration is what helps keep all the planets in their paths. With Pluto and Neptune, it means that when Pluto crosses Neptune's path, it is far off to the side. This prevents them from coming face to face. Latitude vibration refers to how much a planet moves up and down in its path. For Pluto, when it gets close to Neptune, it's far above Neptune's orbit. That gives it an extra layer of safety. Then there's the VSSs, named after scientists Vonopolkai and LV, who studied how celestial bodies move in space. It helps us understand why Pluto's path is so strange. Even though it seems all over the place, this gravitational balancing act keeps it stable over time. All of this keeps Pluto's orbit safe, preventing it from crashing into Neptune or getting lost in space. Studying this helps us understand Pluto, other distant worlds, and their stars. Back in the 1980s, computer models showed that Pluto's path is actually a bit chaotic. Tiny changes can cause big differences over millions of years, but these quirky characteristics keep its orbit steady for a very long time. Newer computer simulations help us understand how big planets like Neptune, Jupiter, and Saturn affect Pluto's path. Neptune and Pluto are connected in a special way. For every 2 orbits Pluto makes around the Sun, Neptune makes 3. This helps keep Pluto steady. Jupiter's gravity also plays a major role in maintaining this balance, and even Saturn contributes a bit. These models show that Jupiter's gravity alone could keep Pluto on a stable path for billions of years. Seriously, Neptune, Jupiter, and Saturn all work together to keep Pluto safe in space. Without these gravitational balances, our solar system would be chaotic. Planets like Pluto could crash into one another or get knocked out of their orbits, which would affect other planets as well. Figuring out Pluto's orbit is extremely important. It shows how chaotic orbits can still be stable thanks to gravity and planetary motion. This highlights the importance of continued observation and study, to better understand our place in the universe. By checking out distant celestial bodies, scientists face the unstable nature of space. Pluto's orbit exemplifies that. Using computer models, they simulate how Pluto and other space bodies interact. Even tiny changes in the data can send Pluto on a completely different trajectory. Back in the 1980s, models revealed something incredibly interesting. Although Pluto's path remains fairly steady, its movement is unpredictable. If you begin with just a tiny difference in Pluto's position or speed, the resulting orbit looks completely different after many years. Despite all that, Pluto remains steady over billions of years. Predicting space events like these is incredibly challenging, especially because space bodies are so unpredictable. These models require very precise starting conditions. Even a small error can lead to completely different results. This is a core challenge scientists face in their work. Pluto stands as a reminder of that challenge. The gravitational effects of the larger planets give us insight into the structure of the solar system. Each planet's position has effects that ripple out, influencing the paths of distant bodies. So, why are some astrophysicists expressing concern now? Tyson has a view on Pluto. He talks about how scientists constantly learn new things about space. Koku demonstrates why it's essential to keep learning. He has a futuristic view and helps make science more accessible to the public. Both Tyson and Koku agree, space still holds countless secrets. Most scientists do. They also recognize that Neptune and Pluto are not set to crash into each other anytime soon. As they continue along their current paths, scientists will keep a close eye on them to study their movements. Okay, so Pluto's that dwarf planet way out there, right? It used to be a planet, but things changed. Anyway, some big-name astrophysicists like Neil deGrasse Tyson and Michio Kaku have people talking again. They brought up this idea that Pluto might crash into Neptune. Sounds crazy, right? But how could that even happen? What would it mean? Are we seeing something unusual in space, or is there more to the story? Pluto's orbit is so bizarre that it takes 248 years to complete just one revolution around the Sun. Its orbit is a weird, squashed oval, not a neat circle like most planets, and it's tilted. Here's the wild part. Pluto's path actually crosses Neptune sometimes, for about 20 years. During that period, Pluto is even closer to the Sun than Neptune. So why haven't they crashed? Because when Pluto crosses Neptune's orbit, it's far away from Neptune. They don't line up. Also, Pluto kind of bobs up and down, it misses Neptune's plane. And then there's this thing called the VSS's thin gummy, a placeholder name in your original text, based on work by scientists who studied orbital mechanics. This essentially means that Pluto's orbit, while weird, is steady in the long run. Back in the 80s, scientists ran simulations and found that Pluto's path is pretty chaotic. Tiny changes could make a huge difference over time. But thanks to Neptune, Jupiter, and even Saturn, Pluto's orbit remains stable. For every 2 laps Pluto makes around the Sun, Neptune does 3. They're in sync. Jupiter exerts just enough gravitational pull to keep everything balanced, and Saturn contributes a little too. Without this gravitational harmony, our solar system would be a. Most scientists agree that Pluto and Neptune are not on a collision course, not now, and not for billions of years. Despite the dramatic headlines or speculative discussions from popular science communicators like Neil deGrasse Tyson or Michio Kaku, the physics behind Pluto's orbit is well studied and surprisingly stable due to a phenomenon called orbital resonance. Here's why a collision is extremely unlikely. 1. Orbital resonance. 3:2 Pluto and Neptune are locked in a 3:2 resonance. That means for every 3 orbits Neptune makes, Pluto completes 2. This resonance ensures that their closest approaches are always safely timed so they never get too close to each other. It's like a cosmic dance with choreography so precise that they avoid crashing despite their paths crossing. 2. Inclination and eccentricity. Pluto's orbit is highly inclined and elliptical compared to the relatively flat orbits of the main planets. Even during the 20-year period when Pluto is technically closer to the Sun than Neptune, it's well above or below Neptune's orbital plane, not actually in the same space. 3. Gravitational stability. Studies and simulations, both from the 1980s and more modern supercomputer models, show that gravitational tugs from Jupiter, Saturn, and Neptune work together to keep Pluto in check. These giants act like guardians, subtly adjusting Pluto's orbit and preventing it from becoming chaotic. 4. Chaos versus stability. While Pluto's orbit is technically chaotic, meaning small changes can amplify over tens of millions of years, this chaos is bounded. Current models predict orbital stability for billions of years, barring an unexpected external force, like a rogue planet or massive object from outside the solar system, which we have no evidence for. Pluto and Neptune are fine for now, since there is this balance that keeps them apart. But with that said, it is important to monitor them in case there are changes, even though a crash is very unlikely. It shows why we need to keep researching and watching space. Getting better tech and computer programs helps scientists get more certain info so we know more about space. Tyson and Koku want to continually explore with flexible minds. The potential impact demonstrates the complex material that exists in our solar system and serves as a reminder that there is still a lot to know. We should keep trying to figure out more. Studying Pluto's orbit helps us think about the solar system as a whole. All the planets, moons, and dwarf planets are connected, making it easier to predict what will occur, even in a very difficult manner. Even though Pluto seems chaotic, forces keep it pretty stable. But any unexpected change could cause havoc, which is why we need to keep watching these distant worlds. They claim that Pluto might run into Neptune. Sounds crazy, right? How could that even happen? And what would it do? Let's check out why people are even thinking about Pluto bashing into another planet. Pluto's orbit is super strange. It goes around the Sun every 248 years, that's nuts. And instead of going in a neat circle like the other planets, it's more of an oval shape. Plus, it's tilted compared to everything else. Here's the kicker: Pluto crosses Neptune's path for about 20 years of its orbit. It's actually closer to the Sun than Neptune during that time. So why haven't they crashed already? Good question. Basically, other planets mess with Pluto's gravity. When astronomers first encountered Pluto, they were scratching their heads about its crazy orbit. It wasn't like anything else. The fact that it crossed Neptune's path just made it even weirder. But somehow, Pluto's orbit stays stable. It's like a really messy dance where everything continues to work out. This is an example of the three-body problem, where you're trying to figure out how three things, like Pluto, Neptune, and the Sun, move around while pulling on each other. What keeps Pluto from smashing into Neptune? Basically, when Pluto crosses Neptune's orbit, it's always really far away from Neptune. Plus, it's usually way above Neptune's orbit, so they don't get close enough to cause a problem. There's also something called the VSSSK oscillation. That's how scientists describe the way Pluto's orbit kind of wobbles smoothly, even though it looks weird. All that keeps Pluto from crashing into Neptune or flying off into space. Researchers figured out that the planets are pulling on each other. Back in the 1980s, computer simulations showed that Pluto's orbit is actually pretty wild. Tiny changes could make a big difference over millions of years, but Pluto's orbit manages to stay stable for ages and ages. Other tests show Neptune, Jupiter, and Saturn all help keep Pluto safe. Neptune and Pluto are linked in a specific way, and Jupiter's gravity is strong enough to keep Pluto stable for billions of years. Without all these things, our solar system would be way more chaotic. Planets could collide with one another or get thrown out of the system. Understanding Pluto's orbit helps us understand how space works. Pluto shows how even orbits that seem unstable can stay balanced because of gravity and how things move. Space exploration necessitates dealing with objects that don't always make sense right away, and Pluto's orbit is a great example. It's a good example of orbital chaos, meaning tiny changes in where Pluto starts can change where it ends up a long time from now. Computer simulations really help scientists understand Pluto's movements. They can change small things in the simulations and see how it messes with Pluto's path. Even with all the things that keep Pluto steady, its orbit can still be quite wild, yet it stays stable for billions of years. Predicting stuff in space is hard, especially with chaotic orbits like Pluto's. We can use computers, but there will be errors in the beginning, so we don't always know where things will end up when trying to predict the future. The fact that bigger planets affect Pluto's orbit shows that everything in the solar system is connected. So why are Tyson and Koku talking about Pluto and Neptune now? Tyson offers his views on the solar system. He thinks changing Pluto from a planet to a dwarf planet was a learning experience. Tyson believes that the more we find out about space, the more questions we ask. Koku has a different perspective. He focuses on how unpredictable space can be. He thinks we need to watch stuff closely and use computers to figure out what might happen. A crash between Pluto and Neptune would show how wild space can be. Koku wants us to consider what might happen if something bad occurs. The better we understand space, the better we can prepare for it. Both Tyson and Koku think space is all about learning new things. Even though we know a lot, we need to keep exploring and using technology. The idea of Pluto and Neptune crashing is a good example that demonstrates how significant space really is. Scientists agree that Neptune and Pluto won't crash because of how they move. Despite gravity, the planets remain monitored and studied just in case. Even though a crash is unlikely, it shows why we need to keep researching space. Better telescopes and computers will help us understand our solar system. Tyson and Koku both agree that we need to explore space and learn as much as we can, while the connection between Pluto and Neptune remains fascinating. This connection between Pluto and Neptune isn't just a curious fact, it's a powerful example of how intricate and delicately balanced our solar system really is. Every celestial object, from the largest planet to the smallest asteroid, plays a role in a dynamic and often unpredictable dance of gravity, motion, and time. It's a reminder that space is not static. It's alive with movement, forces, and interactions we are only beginning to understand. As we improve our technology, our capacity to monitor and simulate these orbital patterns grows. High-resolution telescopes, deep space probes, and artificial intelligence are allowing astronomers to spot subtle variations in orbital trajectories, variations that might have once gone unnoticed. With enough data, scientists can forecast long-term cosmic behavior with greater precision, reducing uncertainty about potential dangers, like planetary collisions, and offering more insights into the formation of the solar system. Tyson often emphasizes that science is a process, a never-ending journey of learning, correcting, and discovering. Reclassifying Pluto sparked public debate, but also scientific reflection. It made people care about space again. Koku, meanwhile, highlights the necessity of being vigilant. He warns that space can surprise us, and only by paying close attention can we be ready for the unexpected. Whether it's through watching Pluto and Neptune or studying exoplanets in distant star systems, humanity's quest to understand the cosmos reflects our desire to understand ourselves. These celestial puzzles teach us humility. We're tiny, but we're curious. And curiosity drives progress. The mystery of Pluto's chaotic yet stable orbit, the gravitational threads tying it to Neptune, Jupiter, and Saturn, and the philosophical questions raised by scientists like Tyson and Koku, all converge into one undeniable truth: space is vast, mysterious, and beautiful. And we've only just scratched the surface.